All right, we are going to continue on with analyzing data and using pandas for that. So pandas, we went over how to read in data and how to start to access some of that data. And so now we're going to continue on with further ways that you analyze data with pandas. So let's reread in that. Import pandas. And then again, we'll read in that file that we were looking at before on single cell sequencing. So again, we have this data where most of the columns are either the gene name or the worm base ID, and then there's also columns for each individual cell type in C. elegans and the expression of the gene within that cell. So for example, ADA has a very high level of expression of this gene, NDU06, but does not express these genes at the bottom, GSD35. So sometimes you want to do summary statistics. So summary statistics is where you group a bunch of data together and then you perform some function on it. So some very common ones are mean. So if you wanted to find the average value, you might want to do that. You might want to sum. You might want to calculate the standard deviation. There's a lot of different of these types of summary statistics that are commonly performed. So you can do this very easily in pandas. So if you look at some of the attributes and methods that are associated with this data frame, some of them will be things like mean, median, etc., and those are examples of summary statistics. So you could try to do something like this. So now we see that we have the mean of all of the columns. So the mean expression of ADA is 70.87. The mean expression of VC. So kind of the way the data analysis was done was to try to force to have all of the cell types have a very similar total expression. So you'll notice that there's this warning that is given to you, and so what this means is that some of the columns you can't do a mean on. So in order to mean a column, you need to be able to add all of the elements together, and then you need to be able to divide by the length of the column. And so this works for most of them, but you can't add the gene name and the worm base ID together this way. And so really, if we want to do this properly, we should drop out the columns that we don't want to do these summary statistics on. So we can do something like this. And did I misspell it? What did I do wrong? Oh, I forgot to say columns equals. And so I've dropped those, and so now I can do something like mean. You can also do median. So if you wanted the median expression, so you'll notice that the median expression is much lower than the mean. And so that is because, for something like ADA, most of the genes are not expressed in ADA. And so some of these cell types, have more than 50% of the genes expressed in them, like ADF, but a lot of them do not. And so this is an example how median and mean can give you very different information. You can also do things like max, the maximum expression. So you see there's a variability in maximum, min, all of the minimum expressions. All of these cell types have at least one gene that's not expressed in it, so that's equal to 0. Standard deviation and kurtosis. So these are all examples of various summary statistics that you might need to use at some point. You can also do something called describe, and so this kind of describes each column, so it gives you the count, so the number so it's kind of like a accumulation of multiple summary statistics. So it gives you a count, how many genes there are for each cell type, the mean, the standard deviation, the minimum, the 25%, the 50%, and then the 75% value. So you can see, like, for all of these, the distribution of gene expressions is very skewed, which is why the kurtosis is high for many of these. And so also you see like the 75th percentage. If you look at the expression of the 75th most expressed gene, you still haven't reached the mean value. And so that is because most cell types are dominated by expression of a few different genes. You can also run these summary statistics on rows. So if you simply change the axis, so if you want it on columns, your axis equals 0, but if you want it on rows, you change the axis to equal 1. And so this is the idea of like a data table is two-dimensional, so you can either run it on the 0 dimension, which is the columns, or you can run it on the first dimension, which is the rows. Okay, so that is kind of the basics of how you can use summary statistics to start to now analyze multiple columns at the same time. And so you can also, for example, combine things that we saw before, like filtering. So if you wanted to filter out genes that had expression less than, a certain value, you can do that. And now you can do mean on just that. So you see the mean has changed, for example. So let's say I wanted to look at all of the genes that were not expressed in ADA, and then I wanted to see what the average expression was in other genes. And so you could do that, for example, by this. So I filtered the data table to only contain the genes that don't have any expression in ADA, and so now I can see the average expression in all the other cell types. So you might notice that it's lower, for example, than the mean expression. So the genes that are less likely to be expressed in ADA have lower expression in all the different cell types. All right, so that is the basics of summary statistics.